I just wanted to add a couple of more items to the advantages of the iFLOW Smart Controller that I missed in our main video. Diagnostics. So diagnostics with the iFLOW Smart Controller are actually very easy. So system diagnostics. So each and every contact on the iFLOW, both on the input side and on the output side, are marked with a corresponding LED light. So when we get 24 volts on any of the thermostat contacts, an LED light will illuminate. When we energize any of the relays on the output side, an LED light will illuminate. So it makes it very easy to troubleshoot and to know what's being called for by the thermostat and then what we are actually activating on the output side. Don't need a multimeter in many cases, so that's a nice thing. You can do it right off the controller. And then actually in test mode on the controller, you can energize any of the relays, and you can do that remotely. So we can remotely diagnose the system and try to turn on the heat pump or turn on the furnace through the app. So we've got a couple of different options. Obviously one in this we're calling on the furnace. And in this screen, we are calling on the heat pump. So I'll go into, I'll expand those up so you can see them a little better, perhaps. So in this scenario, what we've done is we've called on a heating call, the thermostat. I hope you can see this on the display, but we've got a green LED light at W1. So on the thermostat side, we have an LED for W1, W2, G, Y1 and Y2. And then on the output side, we also have LEDs. So on the heat pump, we have Y1, Y2, O and B. And then on the furnace side, we have W1, W2, G, Y1, Y2. But then we also have 24 volts for a humidifier contact as well. So in this case, we're calling for the furnace. So when we've set our switchover point, obviously the temperature now is below that switchover point, so on the call for heat, we're calling on the furnace. That furnace is we're going to output the signal to the furnace, and then the furnace will come on just as it would if the thermostat had been connected directly to that. So not a problem at all there. So in the next slide, we're going to look at the opposite scenario where we get a call for heat. Again, the same call for heat on the W1 from the thermostat. This time, obviously the outdoor temperature is now warmer than the switchover point, so we're going to call on the heat pump. So on this one, you can see the corresponding Y1 and O are energized. You can see that by the red LED light that's illuminated. But in addition, once our suction line temperature sees that 90 degrees from the outdoor unit into the evaporator, then it's going to energize the G and the Y1. So we're simulating a cooling call, even though we're running the Y1 and the O. So we're running the compressor on the Y1, and we're running the reversing valve, so we're going to get heat from the heat pump. But here we're telling it to run at the Y1 fan speed, so at a cooling call fan speed. But again, we're also energizing the humidifier contact. Once that's done, then we send that out to the heat pump, and I don't know if you can see this red LED, the green LED, but we're also energizing Y1 and B on the heat pump. So that's a look at our controller and the diagnostic capability of the controller, which again is something you can't get on any heat pump, on any thermostat. And then we also have an app. So we have a phone app that you can use. It will connect to your local, it'll connect to the home Wi-Fi network and will broadcast out from there. It's available both in iPhone and Android platforms, so not a problem. And I'll just give you a little look at what some of the information that you could get depending on the models. There is a tools app for the contractors, and then there's a home app for the homeowners. So this is the main screen of the app. Once you log in, you have the mode that you're in. thermostat mode or smart mode. So in this case, we're in thermostat mode. We have the address of the location. We have the information because this unit is connected to the internet. It is geofenced the address and has downloaded the weather information. Again, this is the weather information for the area, so it might not be as precise as our sensor, but nonetheless, it's pretty close. So it's a clear day, humidity level is 46, and we've got a 29 degree Fahrenheit temperature. But then we also have the actual outdoor sensor from the heat pump, from the controller, monitoring as well. So it's saying it's 33 degrees. So the actual temperature at the house, at the sensor location, is 33, different from what the weather network by a few degrees. The present thermostat call will be in the middle. So we'll have heating or cooling or fan. You'll be able to see what we're actually calling in real time. And then we have the main floor temperature. So that's looking at the return air temperature and saying, okay, you're at 73 or 72 or 68, whatever the case may be. And then again, the mode. In terms of diagnosing the system, we've got another screen. This will tell us the software version of the controller. It will give us the mode that we're in again. So this thermostat mode. We get the evaporator temperature sensor. So this is the sensor that goes at the top of the evaporator. It's going to tell us what that temperature is. We have the suction pipe temperature. This is the temperature that the heat pump is providing to the evaporator. And then we have the return air temperature. We have the supply air temperature. We have the outdoor temperature. We have the Celsius or Fahrenheit, so the unit of measure that you want. We have the present call. Again, it's a heating call. We saw that in the first screen. It's also repeat. Okay, we've got a heating call, but this time, what are we calling on? Right now, we're calling on the heat pump. We have the G, the Y1 energized on the furnace, and then on the heat pump, we have the Y1 and O for the reversing valve energized on the heat pump. And then another screen, we have the actual menu. These are the changeable parameters. These are the settable parameters on the system. So just looking quickly, we're in iFLOW mode, so we're in outdoor temperature mode, so which means we are going to be switching between furnace and heat pump based on the outdoor temperature. And what is that switchover point? It's been set on this application or this home for 26 Fahrenheit. So it's going to switch over at that point. So when we get a call from the thermostat, the first thing the iFLOW controller is going to do is look outside to see what the outdoor temperature is. If it's above 26, it's going to call on the heat pump. If it's below 26, it's going to call on the furnace. So that's our switchover point. We also have the date and time. The iFLOW controller doesn't have a battery on the controller itself. So if the power goes out to the furnace, power goes out to the controller, power goes out to the heat pump, of course, at the same time, that will have to be reset if you're using any of the peak rate time adjustments. If it's connected to the internet, then as soon as power is restored, it will automatically pick up the date and time so you don't have to reset it. Think of it this way: if you don't have it connected to the internet, it's just like your alarm clock when the power's gone out and it's just flashing 12 continuously. You have to reset it as well. But then we also have these peak rates. So we have peak rate period 1. So this is the start period. What that is for is when we get a call for heat, as I mentioned, we get a call for heat. Let's say the temperature is above 26. So the controller is going to say, okay, I'm going to run the heat pump. So it'll send a signal out to the compressor. But before it does that, it's going to check these two settings. And it's going to say, hey, are we in a peak electricity period rate time? And if we are, then it's not going to run the heat pump. It's going to go back and start the furnace. So it says, okay, we get a call for heat. Outdoor temperature is warmer than 26, so run the heat pump. But check, are we in a peak rate period? Oh, we are in a peak rate period. Okay, I don't want to increase your electricity bill unnecessarily, so I'm going to run the gas furnace at this time, if you've set that period. So what this homeowner has done is they've set the peak period starting at 7 a.m. and ending at 7 p.m. So during the day, Monday to Friday, even though the temperature might be above 26, it's going to run the furnace during that period. So what we do is we set the start time of the peak period 1, and then the end period of period 1, and then we also have a second period if you want another option to set. So that would be the start of peak rate 2 and the end of peak rate 2. So this is the... you can do that on the board as well. You don't necessarily have to set that up on the app, but you do also have access to it on the app to be able to set. So these are 2 items that I missed on my first recording, so I just wanted to add those to the presentation. Thank you again for your time.